Hey everyone and welcome back. Now in today's video we'll look into how we can validate the Terraform configuration files with the help of Terraform validate command. Now Terraform validate primarily checks whether a configuration file is syntactically correct. Now it can check various aspects like unsupported arguments, undeclared variables and others. Now this can be better explained with this diagram where on the left hand side you have the entire Terraform code, and when you do a Terraform validate it basically shows you the output over here. So within the output here you see that there is an error which states that there is an unsupported argument, and it also shows you what exactly is the unsupported argument, that is sky is equal to blue. So this sky is equal to blue is not supported under the AWS underscore instance resource. So this way you can quickly identify if there are any mistakes, if there are any undeclared variables and so on. So let's quickly jump into the practical so that this can be better explained. So for today's demo, we have a terraform-validate.tf file, and this is a genuine file where everything is working as expected. So from the CLI, if you do a terraform validate, so in the output it shows success, the configuration is valid. So everything seems to be fine. Now you can try the same example that we had showed within the screenshot where you add a unsupported argument which is not supported under the resource of AWS instance. So let's save this up. Let's clear the screen and run the terraform validate command yet again. So immediately now you see it gave an error stating that there is an unsupported argument, and it also shows you what exactly is the argument that is unsupported. So this is one part. The second part is that even if you have undefined variables, that is also something that it will be able to verify. So let's use that as part of our demo. So instead of specifying the exact value here, let's define a new variable of instance type. And let's go ahead and save this. Now from the CLI, let's do a Terraform validate. And now you see it is basically giving a new error saying that the reference to undeclared input variable, and it also shows you which exactly is the input variable that has not been declared. So this is one great approach in which you can quickly verify that the configuration that you have written is a working configuration or not. Now do remember here is that whenever you do a Terraform plan, again the validation happens based on your configuration file. So you see when you do a Terraform plan, ultimately behind the scenes the validation happens, and you will see the same type of error when you were running a Terraform validate command. So that's the high level overview about the need of Terraform validate command. I hope this video has been informative for you, and I look forward to seeing the next video. Hi everyone and welcome back. Now in today's video we are going to discuss about the Terraform taint. Now before we understand the benefits that taint provides, let's take a simple use case which allows us to understand the challenge that organization faces. So let's assume that an organization is completely using Terraform for creating and managing the infrastructure. Now in real world scenarios in lot of organizations, one of the common things that you will see is that there will be some team member who will always edit the resource manually. So let's assume that users have made a lot of manual changes to the infrastructure. Now this can be at an infrastructure level, or maybe they have logged into the server and they have manually changed a lot of things. Now although this is a quick way to get things working, but if you want to create a similar resource in a different environment, since lot of manual changes were done, the Terraform will not be able to get things working similar to the older environment, because in older environment the resource were manually managed along with that of Terraform. So this is the reason why it is very important that whenever you make manual changes, first of all you should not make, but in case if manual changes were made, it is important that you import those changes to Terraform. So tomorrow if you want to create a new replica environment in a different account altogether, you can directly make use of Terraform easily. Second approach is you can also delete and recreate the resource. Generally what happens if someone has manually logged into the server, they did some configurations, things are not working at all. So what you want to roll back to the working set of infrastructure. So in such cases, you can delete and recreate the resource. So Just to revise, you have a Terraform managed resource, you have users, and users have made a lot of manual changes. Now these manual changes are not tracked at the Terraform level. So in a new environment, when you run the Terraform configuration again, the Terraform managed resource in the new environment will not meet the similarity of the resource in the older environment. Now, as we're discussing, it can happen that the users have made some changes to the server due to which things are not working. So you want to revert back to the working version of infrastructure that was originally created through Terraform. So in such use cases where you want to recreate the resource, you can make use of taint. So Terraform provides the -replace option with the Terraform apply to force the Terraform to replace an object even though there are no configuration changes that would require it. For example, you have a Terraform, you have a EC2 instance. Someone has logged into the EC2 instance, made lot of changes, and your application is down. So in order to get back to the original intended infrastructure that you had added as part of Terraform configuration file, you can use the replace flag. So this is how it would look like. Terraform apply -replace followed by the resource address. In this case, AWS instance.web. So when you run this command, what Terraform will do, Terraform will destroy this specific EC2 instance, and then it will go ahead and recreate a new EC2 instance from the configuration file that Terraform has. Alright, so this is a newer set of EC2 instance altogether. So let's do one thing before we proceed further. Let's go ahead and quickly try it out. So for today's demo, I have a file called as taint.tf where I have specified the provider credentials, and we have a simple resource block which creates a EC2 instance. So first, let me go ahead and create this EC2 instance. Now from the CLI, I'll quickly do a Terraform init. Once this is done, we can go ahead and do a Terraform apply just to quickly save some time here. You can review the changes, and once reviewed, you can press Y. Great, so our infrastructure is getting created, and after 26 seconds, our resource is successfully created. Now within the North Virginia region, if we look into the instance, you see one EC2 instance is created. So here let's assume that someone has manually logged into the EC2 instance and they made a lot of changes to the instance, due to which the application that was part of the instance is no longer working. So what you want to revert back to the original infrastructure where your application was running. Now here one thing to note is that this AMI ID, this is nothing but the ID of the image from which the server will get launched. Generally in organizations that are based on AWS, they'll have an image where the application is already configured. And what you need to do, you can launch the EC2 instance from that specific image and your application would be working pretty well. Alright, so let's assume that your application is messed up, things are not working, and you want to recreate the instance once more. So in such cases, at this stage, if you'll do a Terraform apply, let's try it once more. Here you see it states no changes, your infrastructure matches the configuration. However, if you'd like to recreate this specific resource, what you can do, you can say Terraform apply -replace, and within here you can specify AWS _instance dot name here. In this case, it is my EC2. So I'll say my EC2. Let's press enter. Now here you see it states one to add, one to destroy. And if we go a bit up, we can see here that the EC2 instance will be replaced. So just for the workflow, let me just type yes and see on what happens here. So first it is destroying the earlier EC2 instance. At this stage, the destruction process is complete. So the older EC2 is destroyed and now it will start to create the newer EC2. Great. So our new EC2 instance is created. Now if you'd like to verify, you can just refresh it. And you see one instance that is running. In fact, let me just deselect this so that we also see the terminated instance. So the older instance is terminated and the newer instance is recently created. Alright, so I hope with this you understood the basics of recreating the resource through Terraform. Now before we conclude, certain important pointers that you need to keep a note of. First one is that similar kind of functionality that we are discussing was achieved using the Terraform taint command in the older version of Terraform. However, from the Terraform version 0.15.2 and later, HashiCorp recommends that you make use of -replace option with the Terraform apply instead of Terraform taint. So in exams or even in real world scenarios, in case if you hear the term Terraform taint, it is nothing but recreating the resource that were already created through Terraform. Alright, so that's the high level overview, and with this we'll conclude today's video. Hey everyone and welcome back. Now in today's video we'll be discussing about the splat expression. Now at a high level overview, splat expression allows us to get a list of all the attributes. Now let's understand with an example where you have a resource of type AWS IAM user and you are making use of count of 3, so that basically means a total of 3 IAM users will be created. Now within the output ARN, you are specifying the AWS IAM user.lb followed by this splat expression followed by the attribute of that resource, which is ARN. So what will happen is, even if you are creating 100 IAM users, the ARN attribute associated with this resource will be listed for 100 users. So let's go ahead and try this out in detail. So currently I am in the documentation page associated with the resource of AWS IAM user, and if you look into the attributes, there are 3 primary attributes. One is the ARN, second is the name, and third is the unique ID. So we'll be using the attribute of ARN for today's demo. Now in this specific demo example, we are making use of count of 3 and you also have a count of index. Now for the count of index, we already know that it starts with 1. So when you have a count of 3, it basically means 0, 1 and 2. Now whenever you want to see a attribute in terms of output for a specific IAM user, you can make use of a 0, a 1 or a 2. So let's see that first, post which we'll be discussing about splat. So let's put a 0 over here and see what happens. Now let's quickly do a Terraform plan. Great. So as expected, there will be a total of 3 IAM users that will be created. So if you look into the first IAM user, it has a count index of 0. The second one has a count index of 1 and the third one has a count index of 2. So let's go ahead and quickly do a Terraform apply. I'll do a yes. Great. So within the output, what you see here is the attribute which is ARN associated with the first IAM user, which is IAM user.0. So this is how you can get a specific attribute associated with multiple users or multiple resources that you create with count parameter. Now in case if you want to see the attribute associated with all the users that are being created, instead of manually specifying a 0 or a 1, you can make use of splat, something similar to this. So let's go ahead and see what happens now. So I'll do a Terraform apply yet again. Great. So now within the output, you see you got the ARN associated with all the users that had been created. So that's the very high level overview about splat expression. That's about it for today's video, and I look forward to see you in the next video. Hey everyone and welcome back. Now in today's video we'll be discussing about the Terraform graph. So this is one of the cool features that is available in Terraform. So let's go ahead and explore that. So the Terraform graph command allows us to generate a visual representation of either a configuration or an execution plan. So the output of a Terraform graph is a dot format which can be easily converted to an image. So from this diagram itself, you can easily identify what a Terraform graph does. So in the bottom, you have the provider AWS, and all of the resources associated with the AWS is dependent on that. And you also have this nice little dependency graph which allows us to quickly identify the resources and its associated dependency. So let's do one thing. Let's quickly jump into practical and look into how we can generate these. So for today's video, I have a file called as graph.tf, and this file has 3 resources. First resource is the EC2 instance, second resource is the elastic IP, and third resource is the security group. So what we have done is the elastic IP here, it gets associated with this EC2 instance. So only after this EC2 instance gets created will this elastic IP be created. And now you also have a security group. If you'll see, this security group also has the dependency on the elastic IP. So after elastic IP gets created, will the security group gets created. So the first resource that will be created is the instance, second would be the elastic IP, and third would be the security group. So although we'll not be applying these configurations, we'll look into how exactly we can generate the Terraform graph out of it. So from the CLI, let's quickly do a Terraform graph and we'll output it to a file. Let's call it as graph.dot. Great. Now, if you'll see that there is a file called as graph.dot which is created, and this is more of a text based file, so you can easily read it with Notepad or other editors. Now, if you want to convert this into a nice little image, something similar to what we are seeing now, you will need an additional tool. So one of the popular tools here is the Graph Wiz. So this allows you to quickly perform the visualization as well as the conversion related aspect. So if you see within here, there are multiple executable packages. One is for Ubuntu. So in case if you have a Ubuntu server, you can install with apt-get graphwiz. For Fedora, you have this. For Debian, you have this. Now, if you go a bit down, you also have some packages for Windows. You also have some packages for Mac. So what I can suggest you, for test purpose, you can go ahead and quickly install it in a test server and try it out. So what we'll do is we'll be installing it in a test server which is based on Red Hat Enterprise. So it's basically an Amazon Linux based instance where we'll be installing this, and we'll look into how we can convert the dot format to an image. So currently I am connected to the CLI. If you want to quickly look into what exactly this is basically an Amazon Linux 2 that is available. So you can either create a Amazon Linux 2 based instance in AWS or maybe a CentOS in other platforms. So now let's go ahead and run this command here. I'll do a yes. Great. So all the associated packages have been downloaded. Now what we'll do is we'll quickly copy this file, and within the Linux instance, let's go ahead and create a file with the same name, which is graph.dot, and let me paste the contents here, and I'll go ahead and save this. So this is the dot file. So what we need to do is we have to convert this dot file into an image file. So in order to do that, let's quickly do a cat on graph.dot. So this will basically show you the contents. And now what we'll do, we'll pipe it to this specific dot package. So this is the dot that got downloaded, and we are converting it to a file called as graph.svg. Alright, so when you quickly open up the graph.svg file over here, again you see that you have a text based contents. So let me quickly copy this up, and let's create a new file called as graph.svg, and I'll paste the contents. Let me go ahead and save this. Now from the Windows Explorer, you see that we have a graph.svg that is available. Let's quickly open this up, and we'll open it up with Google Chrome. And now immediately you see that you have a resource dependency graph where you have a provider AWS, where you have the EC2 instance that gets created. After EC2 instance, you have the elastic IP, and after that you have the security group. So that's the high level overview about the Terraform graph. Now one more important clarification which I wanted to share is that I could have easily downloaded this specific software in my Windows, and instead of doing that conversion from Linux, I could have easily done it in Windows itself. But since it would have been Windows centric, I wanted to avoid that, and that is the reason why we included Linux server, where we installed this specific package, we converted our dot file into image, and we downloaded the code of SVG to Windows, and we looked into it in a browser centric view. So in your case, in case if you directly want to do it at Windows, you can also install it for Windows, or maybe you can also install it for the Mac over here. So that's about it for today's video, and I look forward to see you in the next video. Hey everyone, and welcome back. Now in today's video we'll be discussing about saving Terraform plan to a file. Now the generated Terraform plan can also be saved to a specific path in a file. Now this plan can then be used with the Terraform apply to be certain that only the changes that were shown while you were running the Terraform plan would be applied. So this is an example syntax where you do a Terraform plan followed by the out and you specify the name of the file where things will be stored. So let's do one thing. Let's directly jump into the practical so that we understand more about it. So for today's video, we have a simple provider section and a resource section which creates a EC2 instance, and the instance type is t2.micro. So now let's go ahead and do a Terraform plan over here. Now as expected, it will go ahead and create one EC2 instance of the type t2.micro. Now at a later stage, let's assume maybe after 3 or 4 days, you want to run this exact configuration for creating the resources. However, in team-based environment, what happens is that a lot of users, they keep on committing things, due to which the entire resource and maybe its associated configurations might change. So tomorrow, let's say that someone has changed the instance type from t2.micro to t2.large. So after a few days, when you do a Terraform plan, the plan would be different than what it used to be earlier. So what you can instead do is you can go ahead and save this specific plan to a file. So let's clear the screen and let's say out is equal to demo path. Great. So now here you see a message stating that this plan was saved to demo path, and it also states that if you want to apply the plan which was stored in this specific file, then you can do a Terraform apply. So now what happens is, even though if your Terraform configuration has been changed, the instance type is changed, lot of new configurations are added and so on, it will not matter because you will be running the Terraform apply from the file which has stored your plan. Now do note that this demo path file that was created, this is a binary file. So it is not a simple text file that you can see it right away. Great. So let me also show you the apply aspect here. So you do a Terraform apply followed by the name of the file which has stored your plan. So when you do this, it will go ahead and automatically create the EC2 instance that was shown in the plan accordingly. Great. So the instance is now created. And if you look into the Terraform state file, let's go a bit down. Here the instance type is t2.micro. So any configuration, because here within the main file it is t2.large, but the instance that was created is t2.micro. So at a high level overview, I hope you understood what exactly this does. So that's about it. Before concluding, let's go ahead and destroy the resources that were created. Let's do a yes. Great. So that's the basics of saving Terraform plan to a file. Now in the organizations that I have been working with, I have not seen this being extensively used, but it is important for the exams, so we need to know the basics of it. So that's about it, and I look forward to see you in the next video. Hey everyone, and welcome back. Now in today's video we'll be discussing about the Terraform output. Now the Terraform output command is used to extract the values of a specific output variable from a state file. So the overall syntax is something similar to the one in this screenshot, where you have the Terraform output and then you specify the output variable. In this case it is IAM underscore names, and here you see you get the list of all of them. So let's do one thing, let's jump into the practicals and understand on how this would work. So in today's video, we have a simple resource block where we are creating 3 IAM users, and within the output, we are using a splat expression to output the attribute associated with name for all of the 3 IAM users, as well as output the attribute of ARN using the splat expression for all of the three IAM users. So let's go ahead and apply the change, post which we'll be discussing more about the Terraform output. So from the CLI, let's quickly go ahead and do a Terraform apply. Great. So as expected, there are in total of 3 IAM users that will be created. Let's quickly do a yes. So within the output here for the IAM underscore ARN, you see that we have a value associated with the IAM users, and even you have the value associated with the IAM names. So this is fine as of now, but let's assume that after few days you want to see the list of the ARNs associated with all the IAM users. Now there are multiple ways in which that can be retrieved. So whenever you do a Terraform apply yet again, so although there were no changes, but after Terraform apply again, you will see the output values associated with both the ARN and the IAM names. So this is one approach of fetching these details at a later state. The second approach is to directly inspect the TF state file. So let's quickly open the TF state file here. And if you inspect the TF state file, you will see the value associated with the IAM ARN, and you also see the value associated with the IAM name. So this is the second way. And the third way is to make use of the Terraform output command. So here you can say Terraform output, and then you specify the name. Either it can be IAM underscore ARN. So these are associated with the output. So let's call it as IAM underscore ARN, and immediately you see the values are being retrieved automatically. Along with that, let's also try the IAM underscore names, and as expected, the values are retrieved here as well. Great. So I hope at a high level overview you understood the use case where Terraform output would be useful. Hey everyone, and welcome back. Now in today's video we'll be discussing about the Terraform settings. Now within Terraform there is a special Terraform configuration block type which is used to configure some of the behavior of the Terraform itself, such as requiring a minimum version of Terraform to apply your configuration. So the block looks something similar to this. So this is basically a simple Terraform block, and within here there are multiple configuration that you can do. So let's quickly look into one of the configuration setting which is associated with the Terraform version. So there is a specific argument of required underscore version which accepts a version constraint string which specify which version of Terraform needs to be used for your configuration to be applied. So if you'll see over here under the Terraform configuration block, you have required version. In this case, it is greater than 0.12.0. So if any user who is using a Terraform version which is less than 0.12.0, immediately when he tries to run the configuration, he'll get an error. Alright, so this is one of the important Terraform setting that will be very useful. The second important configuration setting is associated with the provider version. So in this case, you specify the required underscore provider block which specifies all the provider that is required for the module and also associated version over here. So this also proves to be useful. So let's quickly jump into the demo so that we understand it in a better way. So currently I have a file called as settings.tf. So this only has a provider and it has a resource block. So let's quickly do a Terraform init, post which we'll be discussing things in more detail. So from here, let's quickly do a Terraform init. Great. So here it has downloaded the provider. The version is 3.5.0. So now let's quickly add a Terraform block. So I'll say Terraform. And first one is the required version. And within here, let's say the version should be less than 0.11. We'll go ahead and save this. And from the CLI, let's quickly do a Terraform plan. So here you see you got an error of unsupported Terraform version, and it states that this configuration does not support the Terraform version 0.13 that we are currently using. So depending upon the Terraform version that you require, you can explicitly specify a required version here. Now, one of the use cases here is that since there have been a lot of changes between 0.11 and 0.12, you can explicitly within the required version, you can say that a user need to have a 0.12 version or higher. So depending upon the code, some code are specifically designed for 0.11 version, some code are specifically designed for the version like 0.12 or 0.13. So you can specify the exact required version over here. So I hope at a high level overview you understood the setting associated with the Terraform version. The next one is the provider version. So let's quickly try this out. So let's specify required providers. The provider that we need is AWS, and let's specify the version of 2.0. Along with that, let's remove the required version now, and let me save the change. Now in the folder where we actually are running this configuration file, let's quickly look into the exact version of the provider. So the exact version is 3.5.0. So from the CLI, let's quickly go ahead and do a Terraform init. So now here you see it is trying to find a specific provider in this range of 2.0, and it is installing a provider of 2.70.0. Great. So our Terraform has been successfully initialized. Now one more important part to remember is that the provider version you can even specify within the provider block something similar to this, but from 0.12 onwards this is something that is not recommended, and you can put it as part of the Terraform settings itself. Great. So I hope at a high level overview you understood the basics of Terraform settings. Hey everyone and welcome back. Now in today's video we'll be discussing about dealing with larger infrastructure in Terraform. Now whenever you have a larger infrastructure, maybe you're managing it through console, Terraform or any other scripts or infrastructure as code tool, you will face issue related to the API limits for a specific provider. So let's take an example. So let's assume on the left hand side you have a infra.tf file, and within here you have four resources that you have specified. You have a EC2, you have a RDS, you have a security group, and you have the VPC infrastructure. So let's assume that all of these things are created. Now whenever you do a Terraform plan, the first thing that would happen is the updation of each resource. So a Terraform refresh would happen, where depending upon the amount of resource, the amount of calls that would be made to the overall AWS provider might also increase. Now, there are two disadvantages here. First one is the overall API call can increase. Second one is that it can slow down the operations for you. Now, I'll give you one of the examples. So, I used to take care of the AWS hardening with the help of Terraform for one of the organization, and the organization, they used to have hundreds of accounts. So for 99% of the account things went pretty well, but only for 1% of the account which had thousands of servers, we were not allowed to run our hardening scripts there. So there was a blockage, primarily because that AWS account were already reaching the API limits there. And if we ran our Terraform hardening code there, which used to create a lot of things like VPC flow logs, security hub, AWS config, CloudTrail, and so many other things. So due to those reasons, there were chances that the API limit would had reached the threshold and the production would had got down. So for that 1% of the accounts, we were not allowed to directly run our hardening code there. And there were a lot of optimization and lot of compromise that we had to do in order to get it running for those pending accounts. So whenever you're working at a larger infrastructure level, you need to take care of so many other things as well, apart from just writing the Terraform code. Now, when you discuss about dealing with the larger infrastructure for the exams, the primary aim here is dealing with the larger infrastructure which is part of the same project. So for example, instead of defining all of the four resources within the infra.tf, and when we know that if we do a Terraform plan, there would be a refresh that would happen for the current state for all of the resources that were part of the infra.tf, and that will lead to a lot of time. So instead of that, what you can do is you can divide all of these files into a separate projects all together. So you can have one folder for EC2, one folder for RDS, one folder maybe for security group, and one folder for VPC. So this is just an example. So in such case, what would happen is when you do a Terraform plan, only the resource related to the EC2 needs to be refreshed. The other resource like RDS, security group, VPC infrastructure would not need to be refreshed, and that can save you a good amount of time. So one of the key thing that you need to remember here is that it is important to switch to a smaller configuration where each can be independently applied. This is one of the keys here. Now, one of the question that comes is what happens if someone has already done that. So let's assume that there is an organization, they have an infra.tf where they are already specified VPC, security group, RDS, EC2 and lot of other things within the same project itself. So how can you deal with such kind of offering? So what you can do is, in order for Terraform to be prevented from querying the current state for all the resources during the operation like Terraform plan, you can stop the refresh with the help of -refresh is equal to false flag. So this is something that you can do, and it can make sure that things becomes much more faster here. Alright, so when you do a Terraform plan with refresh is equal to false, in this configuration, in this first configuration, then what will happen is this specific update state on each resource that used to happen during the Terraform refresh phase, this will not happen. Alright, so the amount of API calls will also reduce. So this is one way. Second way is you can directly specify the target. So the target is equal to resource flag can be used to target a specific resource. So for example, let's say that you have modified something in the EC2. Now in the Terraform plan, if you do, associated with the Terraform plan, Terraform refresh will run, which will go ahead and fetch the current state of all of the infrastructure. So instead of doing that, what you can do is you can specify a target is equal to EC2. So it will only look into the EC2 specific resource. No other things will be looked upon. Alright. So this is generally used to operate on an isolated portion of a very large configuration if it is present. So let's do one thing. Let's jump into practical and look into how exactly this might look like. So for today's demo, we have few resources. One is the VPC resource. Second is the security group resource, and third is the EC2 instance resource. So let's do one thing. Let's go ahead and do a Terraform apply, post which we'll be discussing things in more detail. So let's quickly do a Terraform apply with auto approve. Great. So all of the resources are created. So in total, if you see, there is 21 resources which are created. Now let's assume that you want to add one more rule. So let's create one more rule over here. So this rule would be for HTTPS. Let's change the port from 80 to 443. Now we'll save the change, and from the CLI, let's quickly do a Terraform plan. Great. So it is stating that there is one change. However, the primary thing that we are looking for is this refreshing state. So we have already seen that there were 21 resources that were created. Now what would happen is anytime when you do a Terraform plan, it will go ahead and refresh the state associated with all of the 21 resources. Now assume that there are 100 resources that you have created as part of the same folder. So before you do a Terraform plan, it will refresh the 100 resources that were created. So not only it will slow down your overall operation, but it can also increase the overall API calls that is being made to the provider. So this is what we are looking into in today's video. So what are the options if you have already done that? So let's explore. So I'll clear the screen. So the first thing that we have seen is you can go ahead and specify refresh is equal to false. Great. So now if you go a bit up, here you see that there was no refreshing of state of all of the 21 resources that had taken place in the previous step. So this is one important part to remember. Along with that, also remember, because this is important for the exams. So this tilde basically means that there is an update in place. So sometimes in exams there can be a question which states that you are seeing this tilde mark within your Terraform plan. So what exactly this means? So this basically means that there is some update which is going in place. Anyways, so coming back to the topic, I hope you understood what happens when you specify refresh as false. Now, second thing is you can directly also look into the target. So you can also specify a target. However, before we do that, let me quickly show you one thing. So let's also modify the instance type. Let's say from T2 medium to T2 small. So now let's go ahead and do a Terraform plan. And now you see that there are two changes. One is related to the security group and second one is related to the instance type. In fact, the instance that we had created was based on T2 medium. So what I'll do is I'll change it to T2 micro while committing the code to GitHub, so that if you create the resource, it comes under the free tier account. So that is something that we'll do. Anyways, so now even though the refresh is false, it is showing you the update related to all the changes that have been made to the configuration file. So now with the help of target, you can specify the exact target. Let's try it out. So I'll say target, and within the target, let's use the AWS security group followed by allow SSH con. So I'll say allow SSH con. Let's press enter. And now you see only one resource is up to change. So this is related to the security group. There is no change. It is showing as part of the EC2 instance. And also you see a warning that resource targeting is in effect. And if you look into the description, it also gives you a little warning stating that the target option is not for the routine use and is provided only for the exceptional situations. So that's a very high level overview about some of the challenges that you can face if you have a larger infrastructure which is configured within the same directory. Now again, one important part to remember is that the things that we are discussing, like refresh is equal to false or maybe a target, you can consider it more of a hacky way in case if you have already made a very big infrastructure configuration in a same directory. However, for production use, it is important that you do not set the refresh as false and also do not set the target is equal to resource. This is not really meant to be used extensively within the production environment. However, for exams, it is important to know on how you can deal in case if the infrastructure is made in a way where a lot of resources are part of the same configuration. So with this, we'll conclude today's video. Hey everyone and welcome back. Now in today's video we'll be discussing about the zip map function in Terraform. Now at a high level overview, the zip map function constructs a map from a list of keys and a corresponding list of values. So let's take an example. So let's say you have a list of keys and the keys are pineapple, orange and strawberry. And then you have a corresponding list of values. The values are yellow, orange and red. So these are basically the color associated with the given fruit. And then if you make use of zip map, then from both of these lists, the zip map will go ahead and construct a appropriate map over here. So let's take an example. So let's say you have a list of keys here, pineapple, oranges and strawberry, and you have a list of values, yellow, orange and red. So if you use it along with the zip map, then you see you get a corresponding map within the output. So let's do one thing. First, let's go ahead and try it out, post which we'll be discussing things in more detail. Now, if you look into the documentation associated with the zip map function, this is the high level syntax. So you have a zip map followed by the key list and followed by the value list. And within the example here, it becomes pretty easy to understand. So you have a list of keys, you have A, B, you have a list of values 1 and 2, and then a map is constructed out of it. So let's try it out. So from the CLI, let's open up the Terraform console. And in fact, let's copy this example here. And when I press an enter, you see a output something similar to this. Now, similar to the example that we have within the PPT, if we make use of zip map for pineapple, oranges and strawberry with yellow, orange and red, if I press enter, you get a corresponding output here. So this is the high level overview on what zipmap function does. So let's take a sample use case that allows us to understand where it might be used. So for example, let's say that you are creating multiple IAM users and you need an output which contains a direct mapping of IAM names and ARNs. So here you see that you have a zip map with the name of the IAM users and the ARN associated with those IAM users. And this type of approach becomes much more easier to go through, specifically if you have it as part of the outputs. So let's try it out. So for today's example, we are basically creating 3 IAM users. So the count is 3, and within the output, we have a ARN as well as the name which would be displayed. So let's come out of the Terraform console and let's go ahead and do a Terraform apply with auto approve. So now within the output, after the 3 IAM users are created, you get a separate output containing the ARNs and you get a separate output containing the names. Now this in fact can lead to a little amount of confusion, specifically if you have various other resources like SQS queues and others that you are creating as part of your project. So now what you can do is to make sure that things are much more easier to read, you can map the IAM username with the appropriate ARN associated with it. So this can be done with the help of zipmap. So now what you can do is you can have an output of combine. So this is just for an example, and the value here would be a zip map, and similar to the syntax that is being shown where you specify a key list and a value list, we can go ahead and copy this up. Let's paste it. We'll add a comma and then we'll copy the second one which is associated with the ARN. Let's save this, and from the CLI let's do a Terraform apply on auto approve. And here if you look into this combined part here, it becomes much more easier. So the IAM user 0 has this specific ARN, IAM user 1 has this specific ARN, 2 has this specific ARN, and so on. So I hope at a high level overview with the help of this demo use case, you understood how zipmap function can be useful. That's great. So with this, we'll conclude today's video. Hi everyone and welcome back. Now in today's video, we'll be discussing on how we can add comments in Terraform code. Now for the individuals who are coming from programming background, adding a comment to the code is something that they must be already familiar with. So in today's video, the primary aim is to understand how this can be done as far as Terraform is concerned. So just to quickly revise, a comment is a text node added to the source code to provide a explanatory information, usually about the function of the code. So this can be better explained in this screenshot. So in this screenshot, you have a specific Python code over here. Now, even before reading the code, you will see that there are certain set of comments that are added. So in the first 3 lines, let's say what it states. In this program, we check if the number is positive or negative or 0 and display an appropriate message. So even before reading the actual code, you get to understand what is the primary aim that this code allows you to do. So the first 3 lines are comments over here, and you also have another 3 lines over here, and these are also a set of comments. So when there are comments that are added to the code, it becomes much more simpler to go ahead and look into what exactly the code does. And this is also one of the recommended things to do. Now, one important thing to note is that depending upon the programming language that you might choose, the way in which the comments are added might also change. So when we discuss about Terraform, the Terraform language supports 3 different syntaxes for adding a comments. So you have these 3 different types over here. You have a hash, you have a double slash, and you have the third format over here. So the hash basically begins a single line comment ending at the end of line. So this is very similar to the screenshot. You see there is a hash that is added, and after the hash you have a comment. So this is like a single line comment that you can add in the code. You also have a double slash which also begins a single line comment as an alternative to hash, but generally hash is the primary approach used for a single line comment. Now, in case if you have a multi-line comment over here, you can use the third approach type. So let's do one thing. Let's go ahead and look into how things work. So in today's video, we have a simple file called as tf-comments, and it has a specific resource. Now we do not really need to worry what this resource does, primarily because we are going ahead and looking into how we can add a comments in this code. So as we're discussing, one of the ways in which you can add a comment here is by adding a hash. So you can say we are running null provisioner. All right. This is one of the ways in which you can add a comment. Second way, as we're discussing, you can add a double slash as well. So you can say this is second type of comment. All right. So this is one way. But if you'll see, both of them are primarily the single line comment. Now, whenever you have a single line comment, note that the first approach is the recommended one. Then as we're discussing, you also have a third type, which is basically used for comments that span over multiple lines. Now, if you look into the screenshot, the first three lines, so this is a multi-line comment over here. So for this multi-line comment, you'll have to use the third approach. For example, let's say I'll say line 1, line 2, and line 3. Now you can either add a comment something like this. So this is a single line comment, or you can use an approach something similar to this. So if you'll see, now if you'll just add this specific comment over here, so you have a slash star, entire code will be commented out, but we do not really want. So this is the start and you want it to end somewhere. If you do not end it, then the entire code which is below this would be commented out. So let's say I want to end over here. So I'll say star slash. All right. So then this becomes a multi-line comment over here. Many times what happens in real world environment, let's say that you have a set of two resources over here and you want this resource to be available in this file, but you do not really want it to run for the time being. So what you can do, you can comment this out over here. And when you do a Terraform plan, only the highlighted one would run. At a later stage, if you want the second resource to also run, you can just remove the comment over here and things would work as expected. Alright, so I hope at a high level overview you understood what the comments are in Terraform. Hi everyone and welcome back. Now in today's video, our main aim is to understand the basics of meta argument. However, before we do that, one of the prerequisite here is to also understand the basics of resource behavior. Now at this stage, we have been doing a lot of Terraform practicals, and this is the reason why our understanding about resource behavior is already good. But before we go ahead and proceed with the meta argument, just for the sake of completeness, first let's go ahead and revise the basics of resource behavior, post which we'll understand on why meta argument is so useful in Terraform. Now at this stage, we already know that a resource block declares that you want a particular infrastructure object to exist with a given settings. So if you include this resource block as part of your Terraform configuration, and if you do a Terraform apply, Terraform will assume that you need a infrastructure resource with these configuration, and hence the EC2 instance will also be created. And if you remove this specific resource block from your TF file and then you do a Terraform apply, Terraform will assume that you no longer need this specific resource and the resource will be destroyed. This is the basics we already know because we have done this practically many times. Now before we start with the meta argument, let's quickly revise on how Terraform applies a specific configuration that you add in the TF file. First is that the Terraform creates the resource that exists within the configuration file but are not associated with a real infrastructure object in the state. So if a configuration is present in a TF file, but if the state file is empty or the state file does not have the appropriate infrastructure object, Terraform will go ahead and create it for you. Second is Terraform will destroy the resources that exist in the state but no longer exist in the configuration. Similar to how we were discussing, if you remove the resource block in your TF file, Terraform will assume you do not need that specific resource object and the infrastructure will be removed. Third pointer here is that Terraform will update in-place resource whose arguments have changed. For example, let's say that you have a security group rule that allows port 22 from everyone. Now instead of port 22, what you want port 80 to be allowed from everyone. So in such cases, when you change the port 22 to port 80 from your security group configuration, then there will be an in-place resource update that will happen here. And the fourth pointer here is that Terraform will go ahead and destroy and recreate the resources whose arguments have changed but which cannot be updated in place due to remote API limitation. This is also something that you will see. One example that I can say is, let's say that you create a EC2 instance from a Linux AMI. Now you change the AMI ID from Linux AMI to Windows AMI. So in this case, Terraform cannot do a in-place update. Terraform will go ahead and it will destroy the entire EC2 instance based on Linux, and it will recreate a new EC2 instance based on Windows. So depending upon what configuration you are changing as part of a given resource, there will either be a in-place update that will take place, or Terraform will completely destroy and recreate the resource entirely. Alright, so these are some of the important pointers about how Terraform applies a specific configuration. Now, let's discuss about some of the limitations that you might face in production environments. So what happens if you want to change this default behavior that we were discussing in the previous slide? For example, let's say that you have already created a resource through Terraform. Now someone has manually modified that resource directly from the AWS console or from the infrastructure console. Now when you do a Terraform apply, Terraform will try to remove that manual change. However, what happens if you do not want that manual change to be removed and you want to ignore those changes? So this is something that does not fit the default behavior of Terraform, but it might be useful in the real world environment. So let's understand this in more detail, where you are creating a EC2 instance and you are adding a tag, let's say name is equal to hello world. So when you do a Terraform apply, what will happen? A EC2 instance will get created with the tag key of name and tag value of hello world. This is completely fine. Everything is managed through Terraform. Now, let's assume that tomorrow someone has manually modified this infrastructure resource and they have added one more tag manually, and here the tag key is env and the tag value is production. So now what will happen is, since this is not added through Terraform configuration, when you do a Terraform apply, Terraform will go ahead and it will remove this specific manually added tag. Alright, this is the default behavior. But what if you do not want the default behavior? What if you want some kind of a flexibility? Flexibility in terms of, what if you want to ignore this specific manual change? You want this manual change to be present without Terraform interfering with it. So when you have such kind of a use case where you want to change the default behavior of the resource object, this is where the meta argument comes into picture. Now before we discuss more in detail about the meta argument, let's quickly look into this from practical point of view so that our understanding remains to be clear. Now for today's video, I have a file called as lifecycle-meta-argument.tf, and it contains a very simple resource configuration. All we are doing is we are creating a EC2 instance with type of T2 micro, and in the tags here we have defined a tag of name is equal to hello world. A very simple configuration. Let's go ahead and quickly do a Terraform apply. So from the CLI, I'll quickly do a Terraform apply and I'll also do a auto approve. So our EC2 instance is getting created here. Great, and our EC2 instance is created. Now from the EC2 console, we can see that our EC2 instance is successfully running. Now if you look into the tags here, you will see that there is a tag with a key of name and a value of hello world. This is completely fine. Now from the PPT, we were discussing that you have a in-place updates and you have one more approach where Terraform will completely destroy and recreate the resource. Let me also quickly show you this. So when you change certain aspects of the resource, depending upon what exactly is changed, either in-place update will take place or the resource will be destroyed and recreated. So for example, let's say that I change the tag from name is equal to hello world to hello earth. Alright, I'll go ahead and save this change. Let's clear the screen. Now when you do a Terraform plan, Terraform will go ahead and it will try to perform an in-place update on a resource. So that means the resource does not need to be destroyed and recreated. Just a specific configuration or a specific attribute of the resource will be changed. For example, here you see it is changing from hello world to hello earth. Now I'll quickly do a Terraform apply with auto approve once again. Perfect. So the modification has been completed. Now, if you'll quickly refresh here, you'll see that the Hello Earth tag is been reflected as we see. So this is what the third pointer is all about. Now, let's go ahead and try one more attribute change which would match the fourth pointer over here. All right. Now, let's go ahead and find the AMI ID which is not associated with Linux. So we have been using Amazon Linux. Let's go ahead and change the AMI ID to that of Windows. All right. So let's copy the Windows AMI ID here and let me add it here. I'll save the change. Now, when you do a Terraform plan at this stage, Terraform cannot update the existing resource because of the remote API limitation. Now, this limitation is at a AWS level. And now you see what it is trying to do. It is trying to destroy the EC2 instance and it will launch a new EC2 instance from the newer AMI. Alright, so if you'll have to quickly see, this specific EC2 instance will be replaced and you can also see that there is a force replacement here. Anyways, so let's go ahead and revert our change back to the older AMI. So with this, I hope the third point and the fourth point is clearly understood. The next thing that we were discussing is that Terraform will go ahead and when a manual modification is something that it observes, it will go ahead and revert it back. So let's also go ahead and try it out. So this time what I'll do for our Hello Earth instance, I'll add a new tag. Let's say env of production. I'll go ahead and save it. Going back to our terminal, this time when you do a Terraform plan, Terraform will try and remove the env of production tag that we had just added. Alright, so here you see it is trying to remove this specific tag. So let's also quickly do a Terraform apply with auto approve. This is great. And now if I'll just open up the instance, if we look into the tags, you see the tag has been removed by Terraform. So at this stage, we have been discussing about the default behavior in which Terraform works. Now, what happens as we're discussing, what happens if we want to change the default behavior? Because in production, you might have various different use cases where you want to modify certain aspects on how Terraform works. And one of the examples that we had taken here is that a manually added resource or manually added attribute to a resource must be ignored by Terraform so that it continues to exist. So if you want to achieve this, then you have to make use of meta argument. So at a very high level overview, Terraform allows us to include certain meta arguments inside the resource block, which allows us to achieve certain level of customization. So there are multiple meta arguments that you can define inside the resource block. So here you have a meta argument of lifecycle that is being added inside this resource of AWS underscore instance. And inside the lifecycle meta argument, you have specified ignore underscore changes is equal to tags. So now what this will do, this will ignore any changes that have been applied at a EC2 instance level manually. And what are the changes that it will ignore? It will ignore the tags specific changes. All right. So let's go ahead and try it out. So now let's say that I specify lifecycle, and inside the lifecycle meta argument, I'll say ignore changes, and within here, I'll just specify tags. Again, you can have a lot of complexity here, but we are just understanding the basic of meta argument so that our concept is clear. I'll go ahead and I'll save this. Now let's do one thing. Let's go ahead and add the tag also. I'll say env of production again. Let's verify if the tag is added successfully, and yes, it has been added. Now, since we have specified this meta argument, Terraform will now ignore the changes specific to tags as part of the overall plan. So any tag related modifications will completely be ignored. So let's go ahead and try it out. So let's do a Terraform plan once more. This time it should not show any changes. As expected, you see it is not detecting or it is not trying to revert the manually applied tag in the resource. Now, as soon as you remove this specific block of lifecycle, let's save this. Let's do a Terraform plan once more. This time it will detect it and it will try to revert to the base configuration that is defined. Alright, so now you see it is trying to remove the tag of env of production. Alright, so I hope with this at a high level overview, you have started to understand what meta arguments allows us to do, which is to customize the behavior of the resource block in Terraform. Now, one important part to remember is that there are multiple meta arguments that are allowed in Terraform. Lifecycle is one of the meta arguments. There are many others, so let's also quickly look into it at a high level overview. Now within Terraform, there are multiple set of meta arguments as we were discussing. You have depends on, you have count, you have for each, you have lifecycle, we have provider. Lifecycle is something that we were just exploring at a high level overview. Again, this meta argument is more detailed. There is a lot of customization that you can do. Maybe we'll leave it up to the upcoming videos about it. But at a overview, you should know what a meta argument does and various different meta arguments here. Now note that there is also a meta argument called as provider. This is not the provider of AWS that we define at the start of the TF file. This is a different meta argument which basically allows you to override the provider configuration to use for a specific resource. Again, whenever we go ahead and practically work on a specific meta argument, then it will become much more clear. But at an overview, you should know that there are multiple meta arguments in Terraform, and depending upon the use case that you face in production environment, you can use one among them. We'll be discussing about these whenever required, but at this stage we'll keep it simple, and with this we'll conclude today's video.